All right, good afternoon, boys and girls. So I wanted to make a couple of videos about conditional probability to help explain what's going on. I've grabbed this question straight out of your textbook. This is from exercise 9F, and I'm going to use it to have a bit of a discussion about two different strategies for solving problems that involve conditional probability. So in Sam's class, 12 students play violin, 12 play piano and 7 play both. Draw a Venn diagram and use it to find the probabilities that a random chosen student plays the violin given that they play the piano. All right, so let's start off with the first part of drawing the Venn diagram. And let's not overcomplicate this. I'll quickly make a nice diagram here. So here we go, my Venn diagram. Let's say that this first circle is the violin and the next one's the piano. Now when I try and do my Venn diagrams, the first thing I'll do is I'll put in the part that is both of them in the middle. And then I've got 12 students who play violin, so the total circle for violin has to equal 12. I've already got 7 in the middle, so this part will be 5, and it's exactly the same for the piano. So I've got 5 on this side. So it says, use this diagram to find the probability that a randomly chosen student plays the violin given that they play the piano. So let's just use common sense. We already know that they play the piano. So the only kids that I'm really interested in are the ones in this circle here. Okay. I don't care about that 5 that sit outside of that circle because they're not part of the question. We already know that they play the piano. So by using common sense, what's the probability that they play violin given? Now remember this line from the Ed Rollo videos and what we've discussed, and you can see in your textbook, this line we say is given that they play the piano. All right, so we can see straight up we've got 7 students who play the violin and the piano, and we've got a total of 12 students who play the piano. So there's my probability, 7 out of 12. Now, there's also the rule for conditional probability. So that's our common sense approach where we look at a diagram and just consider a reduced sample size. But if I want to work with the rule, and sometimes it's useful to work with the rule, the probability of A given B is equal to the probability of A and B divided by the probability of B. So if I wanted to use this rule and I went back to the beginning and said, all right, so in total I have Sam's class. In total, how many students do I have? Well, I've got 5 plus another 5 plus 7 in the middle. That makes 17 students. So the probability of A and B is 17 out, sorry, got that wrong, is 7 out of the 17 students, divided by the probability that they play piano. Well, that's 12 out of 17 students. So here's the top line, here's the bottom line. And when I divide by fractions, I remember the rule for dividing fractions is I flip the bottom one and multiply instead. So I get 7 over 17 times by 17 over 12. And my two 17s cancel each other out. I've got one on the top and one on the bottom. So the final answer ends up being 7 on 12. Just like we had before, but we've used the formula. Okay, so two different ways of thinking about conditional probability.